requirements about C programming, embedded C versus C programming, about PIC microcontroller, CLCD display, matrix keypad, interrupt service routine, timer, and at last we will implement our project, or we simulate our project in the end. So this is the introduction of a microwave oven. What is microwave oven? Microwave oven is an appliance that cooks food by means of high frequency electromagnetic waves called microwaves. A microwave oven is relatively small box-like oven that raises the temperature of food by subjecting it to a high frequency electromagnetic field. In microwave oven, we use a electromagnetic field which is converted into heat energy. A large amount of heat or a temperature raised in a box-like structure which is used for the cooking purpose. This is the introduction of my project. This project simulates the basic functions of microwave oven using a PIC microcontroller. Here it mimics real life features like setting the timer, starting, pausing, and stopping the cooking process. Here we implement generally three modes of uh, operation of microwave oven. First of all is the micro mode, second one is the grill mode, and at last there is the convection mode. In micro mode, the timer is set to 60 minute, where uh, there is a micro mode where timer is set to the 60 minute and the cooking process is done in this time duration. It is a traditional type of mode, like we are cooking food in our gas burner. It is the same like a traditional mode. Next is a grill mode. Grill mode is different, not much different from micro mode. Grill mode is also set to the timer of 60 minute, and the power uses of grill mode is around 90 watts. So grill mode is also used to grill uh, like uh, non-vegetarians and any other things like sandwiches. We made we made all these things in a grill mode. At last there is a convection mode. Convection mode is a type of mode where we set the timer manually and cook the food by means of manual operation. Now let us look at the requirements of uh, microwave oven. There is a two kind of requirements. First of all, we need a hardware. For the hardware, we need PIC microcontroller, that is PIC 16F877A, CLCD display for showing timer and status, matrix keypad for input, and buzzer for alert. We also use some software applications for programming like MPLAB IDE for programming, XC8 compiler which compiles the program, and PiximLab software to implement or simulate our program or project. Here we use a PiximLab software for overall implementation and simulation of our project. So to understand all this programming and embedded system, we require a fundamental as well as a brief, not brief, we required a deep knowledge of C programming, because the framework or the code run in the C language compiles in the C language. Dennis Ritchie is known as the father of C programming. In 1970, Dennis Ritchie developed the C programming, which is a successor of a previous programming language like COBOL and etc. This is a brief overview of C programming language. C is widely used in embedded systems for its simplicity and efficiency. So this is the why we use C programming in our embedded system. We use one more language, that is assembly language, which is quite difficult as compared to C language, because C language provides the low level access to the hardware, making it suitable for microcontroller and programming. C is used to develop games, an area where latency is very important. Here is the term latency. The latency describes about the lag between audio and video. So if the framework of a game is designed in a C language, then there is very less chances of there is very less chances of latency. A computer has to react quickly to user input. Major part of Windows, Linux, and other operating systems are written in C. We are using different kind of operating systems like Windows, Linux, etc. are written in a C language. So this is the brief overview of a C language, which is very important, and this slide describes why we use C language in our programming, embedded system programming. Now let us look at the basic structure of C programming. The C code contains the following structure: documentation, preprocessor directives, global declaration, the main code, and local declaration, program statement, function calls, etc. The preprocessor directive is first line includes the hash include stdio.h. Here hash include is used to include the standard or user defined header files. Hash define is also used for defining the macros or contents. Then there is a variable declaration. Variables are the named memory locations. We will discuss about variables and all the components written here one by one in detail further. Then there is a main and sum, etc. A variable is a container that stores a value in the kitchen. A variable is a container that stores a value. Like in the kitchen, we have a containers storing for rice, dal, sugar, etc. Similar to the variables in C stores the value of a constant. Here a equals 3 means a assigned the value 3. A equals double equals means equals to, and single equal is used it's an operator which is used to assign the value. Now there is our data types. Each variables in C has an associated data type. It specifies the type of data that the variable can store, like an integer, character, floating, double, etc. There are mainly three main kinds of data types. First of all, primitive data type, and derived data type, and third one is user defined data types. In primitive data types, we use int, float, and character values. In derived data types, we use arrays and pointer. And in user-defined data types, we use structure and union. Each data type requires a different amount of memory and has some specific operations which can be performed over it. Like int and float requires a 4 byte of memory, character requires a 1 byte of memory, array and pointer requires a dynamic memory allocation. Now let us look at brief about the operators in C. An operator in C can be defined as the symbol that helps us to perform some specific mathematical, relational, bitwise, conditional, or logical computation on values and variables. Here plus is used for addition, minus is used for subtraction, double equivalent is used for a equal to, and single equivalent is used for assignment, percentage used for modulo division, etc. Now there is a if-else statement which is used in a C program. The statement, if the most simple decision making statement, it is used to decide whether a certain statement or block of statement will be executed or not. Here is the if condition. First of all, there is if, then we apply the condition, and if the condition is true, then statement is executed and the condition is true, and if the statement is false, then the condition will not be executed. We also use else condition. If the statement in the if condition is not true, then we use a else condition. Now let us look at the loops in C: for loop, while loop, and do while loop. For loop, in for loop, the initialization, test expression, and update expression all lie in the same line after the for loop. But in a while loop, initialization will be performed earlier, and the test expression will be used uh, after the while condition. And here is the body of the while loop and update expression. Do while loop. Here initialization of expression will be done earlier, then we apply the do, which is update of the expression, then we apply the while for the test of the expression. For loop is most commonly used in our programs because it can done the uh, work of while as well as do while in the same code. Functions: invoking user defined functions like addition and displaying the messages. A function in C is a set of statements that when called perform some specific task. It is the basic building block of C program that provides modularity and code reusability. Function, here is the declaration, which first of all we apply the return type, then the name of the function, then parameters of the function. Then there is a definition of a function, and at last there is the body of a function, like which kind of code can be done by using that kind of function. Functions are very important in C program. Every function can do a different kind of work. Now let us look at the pointers in C. A pointer is a variable that stores the memory addresses of another variable. Instead of holding a direct value, it holds the address where the value is stored in memory. Pointers are very important and crucial in embedded system programming. To define the pointer, we use a differencing operator or asterisk, which is used to declare the pointer variable. And we use the address operator, that is ampersand, which is used to return the address of a variable or to access the address of a variable to the pointer. Now there is a difference between embedded C versus C programming. Embedded C is the variant of C which is tailored for the programming of an embedded system such as microcontroller, where a direct hardware interaction is needed, while C is a general purpose programming language used for developing operating system, desktop applications, system software, and other high-level programming tasks. Embedded C directly manipulates hardware registers and peripherals, that is GPIO timers ADCs, using special keywords and memory addresses. It is limited hardware access, typically interacts with the operating system level APIs. Now let's start the embedded system. An embedded system is a small computer built inside a device to perform specific tasks. Unlike regular computers that can do many things like browsing the internet, playing games, and writing documents, embedded systems are designed to do one or more few tasks efficiently. This is the difference between microcontroller and microprocessor. A microcontroller is like a mini computer, but in microprocessor it's just the CPU. In microcontroller, the CPU, memory, and input-output all lie in a single chip, but in microprocessor, there is only memory. There no needs it needs external memory and peripherals to work. PIC microcontroller. Here we are using PIC microcontroller to design or simulate our microwave oven simulation program. The PIC microcontrollers are peripheral interface controller. It is a family of microcontrollers made by Microchip Technology. PIC microcontrollers work by executing instructions stored in their memory. PICs are used because of a peripheral interface of a programming codes, etc. Now there is a project architecture, like the architecture of a project. What is the contents of the project? The project consists of a input unit, that is matrix keypad for setting time and control, processing unit like a PIC microcontroller for controlling the flow, control unit, output unit, CLCD display for showing status and timer, alarm unit, buzzer for end of cooking alerts. This is the basic block diagram of a project, like fan and buzzer are the act as a output unit, matrix keypad act as a both input and output, and display mode timer are act as a output unit. We apply some uh, control or actions in the matrix keypad, then that action will be executed in the microcontroller, and then microcontroller program sends the information to fan, buzzer, and display according to the input applied. We use a PiximLab software to simulate our program, the simulation software that is used for project testing, debugging the code, and overall implementation of a project. PiximLab contains a LED display. Sorry, this is the CLCD display here. There is a fan, matrix keypad, buzzer, etc. There is a CLCD display on which our output we see, and we can select the modes like a micro grill, convection, and one more mode, that is the start mode. Matrix keypad is an input device. Sorry, here is act as an input. We can apply a number of inputs like setting the timer, controlling the start stop functions. The interrupts are very crucial and plays an important role in a microcontroller. Interrupts are the signal that tell a microcontroller to stop its current task and perform a specific functions. Interrupts can be triggered by various sources such as buttons, sensors, serial communication, or other peripherals. Interrupts are useful for making things happen automatically in microcontroller programs. Interrupts can help solve timing problems. Now let us look at the interrupt service routine. It is also a software routine that runs in response to an interrupt from a hardware device or software events. It is also known as an interrupt handler. The ISR is invoked by hardware in response to an interrupt. Their invert interrupts is applied to the main program, then it is forming the loop-like structure with the interrupt service routine and ISR vector table. Timer. A timer is a counter that increments at regular intervals. It is used for generating delays and measuring time. In this project, the timer counts down the cooking times set by the user. PIC microcontrollers have multiple timers like timer 0, timer 1 and timer 2. And timer 0 is used for countdown functionality. Now we are at the end of our presentation, and after that we will implement a live project implementation. The circuit consists of a PIC microcontroller connected to CLCD, matrix, keypad and buzzer, pull-up resistors for keypad inputs, and we are using switches, power supply to run the microcontroller and peripherals. Then the software part here is the code which is written in a embedded C using MPLAB IDE. It includes the modules for reading keypad inputs, displaying output on CLCD, controlling the timer and buzzer. There also we contains a switch operations, switch case operations, and if else for the if else statement, display screen and clear screen operations. We are also using if else key, fan, buzzer, and different kind of codes for different type of program to be run. For that, we first include the header files like clcd.h, main.h, as well as important files and linker files, source files, etc. Now let us implement it on the PIC microcontroller. There in the CLCD display, it shows four modes. First is micro mode, second one is grill mode, third one is convection mode, and fourth is start mode. And for that, we need to apply like the one we apply power of 900 watts in a micro mode. And here's the set timer, 0 for set timer. We apply set time, and there we set time for 1 minute. Then the fan start rotating, which mimics that our microwave oven start working. Press 4 for start, press 5 for a pause, and press 6 for stop. Now let us check the grill mode, and for the grill mode we set the timer. Then we set timer for a 1 minute. Then the fan starts rotating, which mimics that our microwave oven is working. Where also a 4 for a start and resume, and 5 for pause, and 6 for stop.